During systematic interior imaging, remote vehicles detected loose metallic objects scattered across several corridors. Closer inspection identified them as sealed data cartridges, each constructed from a corrosion-resistant alloy and designed to protect contents from environmental damage. Their distribution suggested they had been dislodged during the facility's final operational phase. The cartridges contained intact microfilm reels, a storage method known for its longevity under adverse conditions. Analysis of the microfilm yielded a substantial set of documents, including operational schedules, environmental charts, and progress reports. The earliest entries described baseline studies of deep-sea pressure tolerance across multiple biological samples. Testing focused on structural integrity, cellular response to stress, metabolic rate modulation, and adaptive behaviors. These reports aligned with the architectural indications found earlier. The facility originally served as a biological research station. Over time, however, the content of the documents shifted. Later records referenced the term E-series, though without explicit definitions. References included mentions of growth acceleration patterns, pressure-induced morphology, and resilience tests under shifting environmental conditions. The term appeared repeatedly in sections discussing behavioral monitoring, environmental response modeling, and biocontainment procedures. Charts associated with E-series experiments displayed significant deviations from typical deep-sea organism behavior. Data showed unusually rapid adaptive responses to environmental fluctuations, including temperature gradients and chemical exposure. Several graphs indicated nonlinear growth patterns inconsistent with known marine life. The recurring notation ACM was present beside critical data points, though its meaning remained unclear. The documents also referenced phase progression protocols, suggesting staged experimentation, possibly involving genetic or environmental manipulation. Specifics remained ambiguous, yet the overall structure of the reports indicated that E-series organisms, whatever their origin, were designed or selected for extreme resilience. Mid-period logs contained internal assessments expressing concern over containment systems. Notations indicated that earlier protocols had been sufficient, but later experimental phases required reinforced procedures. Mentions of behavioral variance beyond projected thresholds and cognitive markers exceeding baseline implied increasing unpredictability in experimental outcomes. Several reports detailed modifications to containment pods, including strengthening of internal framing and addition of layered restraint systems. Environmental records from the same period reported irregular fluctuations in atmospheric composition within the facility, attributed to unexpected stress responses from experimental subjects. A series of emergency maintenance logs documented temporary shutdowns of climate control modules linked to overloaded filtration systems. These incidents corresponded chronologically with upward surges in E-series activity reports. One of the most significant document sets involved internal environmental simulations. These models projected potential outcomes if containment systems failed. Scenarios included the uncontrolled release of altered organisms into the surrounding ecosystem. Risk assessments noted that while the deep ocean provided natural isolation, the mobility and adaptability of certain samples introduced unpredictable variables. The simulations did not identify specific consequences, reflecting incomplete understanding of the organism's long-term behavior. The final accessible documents were cryptic, fragmented, and at times heavily damaged. They mentioned threshold surpass events, structural disruptions, and pressure anomalies originating within containment pods. One report described a collective response pattern not associated with typical marine species, implying coordinated or parallel activity among subjects. Another noted that scheduled decommissioning procedures had been delayed due to internal instability. There were references to evacuation protocols, but no conclusive evidence indicated whether they were executed successfully. One microfilm frame included an environmental directive advising that, in the event the facility was abandoned and later rediscovered, the structure should remain sealed to avoid undesirable ecological interactions. While the wording avoided explicit description, the implication was clear. The facility contained or had once contained experimental organisms capable of affecting the surrounding marine environment in unpredictable ways. No personnel logs were discovered, and no external communications were found, reinforcing the assumption that the project operated under strict isolation, possibly to minimize traceability. The absence of metadata, signatures, or institutional identifiers further emphasized the intentional secrecy surrounding the research. In summary, the recovered documents painted a picture of a sophisticated, multi-phase biological research program focused on developing or observing organisms with exceptional adaptability to deep-sea conditions. The increasing caution in later entries suggested that the subjects exhibited capabilities beyond initial projections. The abrupt cessation of documentation indicated a premature termination of the program, though the cause remained uncertain. The records provided vital insight into the facility's purpose, but also introduced new uncertainties regarding the fate of its contents and the implications for the surrounding ecosystem. The final stage of the investigation focused on the deepest accessible portion of the bunker. Structural mapping identified a heavily reinforced circular chamber positioned at the facility's core. This chamber exhibited architectural differences from the rest of the structure, including thicker support beams, multi-layered walls, and redundant ceiling systems. Its design indicated the highest priority containment area. Within the chamber were 12 large containment units arranged in a symmetrical pattern. Unlike the smaller pods found in earlier corridors, these units displayed advanced life support integration, including nutrient delivery ports, oxygenation controls, and multi-stage pressure regulators. Several units showed signs of internal activity before abandonment, such as residual fluid rings and minor structural stress marks. A few contained degraded biological traces similar to those found in the secondary pods, but in greater concentration. Surface scans of the internal glass surfaces revealed irregular patterns resembling contact residue. Some markings displayed elongated impressions inconsistent with known marine species. Others exhibited directional scraping, likely caused by mechanical pressure rather than sediment movement. These findings supported the interpretation that the chamber hosted organisms undergoing active development during the facility's operational peak. The chamber's central console contained a sealed compartment holding a final microfilm strip. This strip contained a formal assessment summarizing the state of the facility during its last operational phase. It described the experimental subjects' accelerated adaptation cycles, noting their increasing responsiveness to environmental stimuli. The assessment also referenced autonomous behavioral patterns that exceeded the research team's predictive models. Environmental logs included in the strip documented irregular seismic level vibrations localized within the facility shortly before operations ceased. These disturbances were correlated with fluctuations in internal containment pressure, suggesting that mechanical strain originated from within the pods. The logs also noted repeated failures of secondary locking mechanisms, implying that the reinforcement upgrades described in earlier documents had been insufficient to maintain long-term stability. A risk projection section recommended immediate deactivation of experimental operations. It outlined environmental concerns associated with potential release of subjects into the open ocean. These concerns included unpredictable ecological integration due to the subject's high adaptability, potential disruption of existing food webs, and unknown interactions with deep-sea chemical gradients. However, the document provided no indication of whether containment remained intact at the time of evacuation. To evaluate biological risk, investigators conducted environmental sampling around the facility's exterior. Samples revealed no trace of anomalous organisms or genetic markers matching the degraded material found within the bunker. This absence suggested either successful containment or natural degradation over time. However, sediment displacement near the rear of the structure indicated possible movement or structural compromise at some point in the past, though no clear breach was identified. Pressure analysis showed that the containment pods remained sealed, though weakened by decades of exposure. The reinforced chamber displayed minor internal warping consistent with mechanical stress. Without additional historical data, determining whether these distortions were caused by internal activity or external environmental factors remained impossible. The final assessment concluded that the facility represented an advanced, clandestine biological research initiative operating outside conventional oversight. It showcased technological capabilities exceeding known historical records for undersea installations of its era. Its primary objective appeared to have involved observing or developing organisms capable of withstanding extreme pressure environments through accelerated adaptive processes. The combination of containment infrastructure, environmental control, precision, and progressive reinforcement measures suggested that the research escalated rapidly, potentially beyond the original scope. Abrupt cessation of operation, combined with the absence of human traces, indicated an emergency evacuation triggered by internal instability. The facility was resealed to the best extent possible, and its coordinates were restricted to prevent unauthorized access. The ecological impact assessment recommended long-term monitoring of the surrounding marine environment, though no immediate anomalies were detected. In the broader context of oceanographic research, the discovery demonstrated the limits of publicly documented scientific history. It revealed the existence of an undersea facility capable of supporting complex experiments far beyond what was acknowledged during its presumed operational period. Although the exact nature of the organisms studied within the facility remained uncertain, the evidence suggested that the research approached boundaries where biological unpredictability rendered continued operation unsafe. The final conclusion emphasized the need for caution in future deep-sea exploration. The ocean's depths remain largely uncharted, and the existence of a facility of such scale illustrates how much may still lie undiscovered. Whether similar installations exist elsewhere remains unknown, but the implications of this discovery extend beyond the technical achievement of constructing a deep-sea bunker. It represents a chapter of scientific ambition, secrecy, and risk, whose full consequences may never be entirely understood. Interest in deep-sea anomalies has increased steadily over the last 2 decades due to advancements in ocean mapping technologies and a growing scientific effort to revisit previously dismissed maritime data. Among the most intriguing discoveries was a geometric formation detected north of the Mid-Atlantic Ridge during a tectonic survey. Initial scans revealed a structure whose angular outlines contrasted sharply with the surrounding seafloor. The shape was too precise to be associated with typical volcanic or sedimentary processes, prompting several research groups to examine the scans independently. High-resolution sonar confirmed the original finding. Beneath nearly 4 kilometers of water lay a large, rectangular object embedded in a depression. The contours indicated artificial construction, with edges consistent with reinforced plating and with reflective densities similar to metallic alloys rather than natural rock. Such features suggested deliberate engineering rather than a geologic anomaly. The location, however, made the possibility of human origin difficult to explain. No known military, industrial, or exploratory operations had ever been recorded in that sector, especially at such extreme depths. Subsequent analyses revealed an entrance-like recess along one side of the structure. Measurements suggested a pressure-resistant access point built to withstand long-term marine exposure. The scale of the construction, combined with its isolation from documented naval routes, raised numerous questions regarding its origin, purpose, and builders. If it was indeed a bunker, as preliminary data suggested, then its placement on the ocean floor represented a significant engineering feat, one that would require resources, technology, and secrecy beyond conventional maritime infrastructure. A descent mission using a deep submergence vehicle was organized to verify the structure visually. The vehicle's cameras captured the first images, a massive outer wall partially covered in sediment, marine growth, and mineral deposits. Despite decades, possibly generations underwater, structural alignment remained remarkably intact. Along the front face of the formation stood a sealed metallic door, bearing markings and coded symbols faded but still visible. These markings did not correspond to any known modern navy or scientific institution. The door's hinges and locking mechanisms suggested a construction date sometime in the mid to late 20th century, although nothing in public archives supported such a timeline. Upon closer inspection through remote-operated tools, the door exhibited slight movement when pressure was applied. indicating that internal collapse had not occurred and that airspace or reinforced chambers might still exist within. The surrounding sediment contained no debris fields or evidence of catastrophic failure, further implying that the structure had been intentionally abandoned rather than destroyed. Oceanographic records showed no previous references to such a facility. However, several Cold War-era documents hinted at classified undersea programs involving environmental research and biological stress testing. These programs were rumored to operate outside conventional reporting channels. Although official sources denied the existence of deep-sea laboratories, the engineering style of the discovered structure aligned with speculative descriptions of such installations. As research continued, attention shifted to the broader implications of the finding. The construction of a pressurized underwater bunker would have required advanced metallurgy, extensive logistic planning, and substantial funding. It would also require a strong motive, one compelling enough to justify building in a location characterized by high pressure, near freezing temperatures, and near total darkness. Such an environment would offer natural containment, isolation from surface monitoring, and protection from satellite detection. Whether these advantages were used for research, experimentation, or storage remained unknown. The discovery revived long-standing debates regarding undocumented scientific initiatives conducted during periods of international tension. Some oceanographers proposed that the structure represented an experimental habitat or long-term observation module built to study deep-sea organisms. Others suggested it could have served as a containment site for materials sensitive to surface exposure. None of these theories fully explain the facility's scale or the absence of supporting historical records. Regardless of its purpose, the structure's existence demonstrated a level of undersea capability exceeding what was publicly acknowledged at the time. The next phase of investigation would focus on internal analysis and retrieving physical evidence that could identify its builders. The structure's interior was expected to contain preserved chambers due to the airtight seal and surrounding pressure balance. What began as a routine geological survey had unveiled an anomaly that challenged assumed limits of undersea engineering. The bunker posed new questions regarding unknown scientific operations of the past, and its remote location suggested intentional concealment. Only further exploration would determine whether the facility had been a research installation, an experimental laboratory, or something more complex. After confirming the bunker's exterior stability, investigators initiated a controlled entry protocol using remote-operated vehicles. The primary goal was structural mapping, environmental assessment, and documentation of internal design. Initial penetration revealed a large central chamber, intact and free of flooding. Its preservation suggested the facility incorporated advanced pressure mitigation systems capable of surviving long-term submersion without corrosion breaches. The interior walls consisted of layered composite plating, combining metallic alloys with polymer-based reinforcement. Laboratory tests later indicated the materials were consistent with experimental compounds developed during the late Cold War for deep pressure field testing. However, no public record mentioned deploying such materials at operational scale, particularly in fully constructed undersea habitats. The central chamber extended approximately 50 meters, with evenly distributed lighting fixtures mounted along the walls. Although inactive, their arrangement implied the facility once maintained artificial illumination. Instrumentation panels lined the chamber, though the designs did not match known scientific, medical, or military interfaces. Their geometric arrangement suggested modular testing stations, each devoted to monitoring environmental variables such as temperature gradients, salinity, pressure tolerance, and nutrient flow. A secondary analysis revealed signs of specialized airflow systems, hinting that the facility supported long-duration human occupation. Ventilation ducts incorporated filtration layers designed to remove biological contaminants, suggesting that the facility's purpose involved handling sensitive organic materials. The absence of debris or decay implied rapid evacuation rather than gradual abandonment. Further exploration uncovered a corridor branching from the main chamber. Remote imaging revealed a row of transparent containment units integrated into the walls. These units featured reinforced glass capable of withstanding sudden pressure shifts, and internal control panels indicated the ability to regulate temperature, pressure, and chemical composition within each compartment. Several units showed residual traces of biological materials, fibrous strands, particulate deposits, and degraded organic matter, though none provided clear identification of the subjects once stored within. Surface analysis of the residue identified compounds associated with preservation agents, hinting that the facility may have hosted controlled experiments on living biological specimens. The combination of pressure-resistant containment pods and adjustable environmental conditions indicated research related to organism adaptation under extreme oceanic pressure. Such studies align with theoretical programs documented in historical proposals, but absent from publicly approved scientific agendas. Structural mapping continued deeper into the facility. The layout followed a systematic grid, suggesting operational efficiency and compartmentalized workflow. Floors incorporated drainage channels not associated with flooding mitigation but with controlled fluid disposal, implying the handling of experimental solutions or culture mediums. Wall brackets indicated that additional equipment was once mounted along the corridor, but had since been removed or decayed beyond recognition. Environmental sensors within the facility remained partially functional. Although degraded, they displayed traces of atmospheric regulation consistent with human activity. Oxygen levels would have been sustained through chemical scrubbing units, while internal pressure was maintained through robust reinforced seals. The design demonstrated a clear intent to isolate internal conditions from the surrounding ocean environment, ensuring controlled variables for scientific testing. As structural mapping continued, it became apparent that the bunker adhered to a level of engineering sophistication uncommon for its presumed era of construction. The precision in panel placement, the integration of composite materials, and the seamless connectivity between power conduits and environmental systems suggested a well-funded, meticulously planned operation. The absence of identifiable signage or institutional branding implied that the facility was deliberately designed to obscure its origin. One of the most significant findings came from analyzing sediment deposition inside the chamber. Patterns indicated that the facility had remained sealed until relatively recently, at least compared to surrounding environmental accumulation rates. This supported the hypothesis that the door's slight movement during exploration was the first disruption of the seal since its abandonment. The physical evidence pointed toward a large-scale research operation specializing in extreme environment biology. Whether the objective involved enhancing organism resilience, studying deep-sea ecosystems, or developing biologically adaptive materials remained uncertain. However, the combination of containment systems, advanced materials, and environmental control mechanisms placed the facility at the frontier of undersea research capability. The structural evidence revealed a facility not only engineered for survival under immense pressure, but optimized for scientific experimentation. Its true function, however, remained obscured behind the absence of documentation, the lack of identifiable design signatures, and the unanswered question of why such an installation had been abandoned. We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.